Hey, welcome back. I'm really excited because Microsoft, in partnership with SafeBreach, released a new attack simulation capability for Microsoft Defender for Endpoint for the Solarwinds campaign. And I'm excited because I want to learn a little bit more about how the Solarwinds Attack Campaign actually works. And so let's head over to the Microsoft 365 Defender portal and let's start running through this attack simulation. Okay, so to kick things off, we're going to go to security.microsoft.com, the home of Microsoft 365 Defender, and we're going to scroll down the left side and under Endpoints, find Evaluation and Tutorials and click on Evaluation Lab. Now, when you click on Evaluation Lab, you'll see something that looks like this. Now, I've done other videos on this in the past, but there's one big change I want to note here. I ran this on just a few days ago, and I've run this a few times in prep for this video. So I've already created my max of 3 devices, and they've already expired after 72 hours. However, Microsoft now has a new feature where you can request more devices. So if you want to keep going through the evaluation lab, you're now free to do so. That's a big deal, in my opinion. So I created 3 devices, 2 Windows 10 and 1 Windows Server machine, Windows Server 2019 machine. And I just went to simulations and I said create simulation. I chose SafeBreach, I chose Solarwinds campaign, and then I chose the devices and I ran on each one. And here you can see that, and it completed successfully. Now, upon completion, it will give you this nice report card telling you how it did. We'll come back to that here in a moment. So that's how you actually launch the simulation. Now on the left side, I want you to click on Simulations and Tutorials, and then scroll down past Microsoft, past Attack IQ, down towards SafeBreach. At the very bottom, you will find the new Solarwinds campaign simulation. And when you click on Learn More, this will allow you to learn a little bit more about it. But I want you to read the simulation document, which is this guy here. Now, we will run through this here in the video today to explore the attack simulation. Now, when you go and run the simulation, it will take probably 15 to 30 minutes. Now, what I did was I ran this probably around 4 o'clock in the afternoon. I just let it run all night. And when I woke up the next morning, that's when I logged in and checked everything. So I would just let this run overnight if I were you, just to give it enough time to do its thing. Okay, so what do you do after you run the simulation? Well, the first thing you do is over here on the left side, click on Threat Analytics. Now, Threat Analytics is pretty awesome. If you haven't seen this before, you're going to want to get to know it. And so this is where Microsoft is tracking 127 global threats, and it can identify threats that are in my environment through various telemetry here. And so there's 3 threats that are in my environment. If I sort by alerts down here, I will see those as active alerts. Check it out. It's all the SolarGate and SolarWinds alerts. And when I click on this, it will give me a ton of great information. What devices are misconfigured for this type of attack? What devices might be vulnerable to this attack? What devices might be impacted by this attack? I can go out and read a really awesome report about this attack and go great technical detail to learn all about the attack chain for this attack and then how to mitigate it. Really awesome. So Threat Analytics is a very useful tool. And you can see here, when I ran the attack simulation, it identified it as SolarGate. Okay, cool. So now over on the left side, click on Incidents, and then you will see a new incident created. Now, I want to point a few things out here. In fact, let's zoom in just a little bit so we can see this. And I'm going to close the hamburger menu. So remember, an incident is a collection of alerts. And so it found all of these alerts to be related with each other. It correlated them and automatically added them to a single incident, making it to investigate this and triage a little easier. Now, it automatically added some tags here: chain event detection and Nobelium. Nobelium's the threat actor associated with this type of threat. And then if I scroll over towards the right here, I can see that there's 2 active investigations, which we'll talk more about later. I see the MITRE attack tactics or categories associated with this, how many devices, how many alerts, detection sources, so on and so forth. Remember, Microsoft 365 Defender is a collection of MCAS, Defender for Office, Defender for Identity, Defender for Endpoint, and so that's why detection sources show up here. Now, this attack originated on my endpoints, and we used Defender for Endpoint to generate the attack. Okay, so we're going to click on the name of the incident. Now, first things first, we're going to take ownership of this thing so nobody else tries to work the incident. So I'm just going to assign it to me. And then for incident tags, I'm just going to say attack simulation. And that way we know what this is. And no classifications yet because we don't know what it is. And we're going to click save. Okay. So at this point, it's time to kick off our investigation. Now, right off the bat, I could see which MITRE attack tactics are associated with this or observed. Now, this is useful because then I can go out to attack.mitre.org and I can go look up these different tactics. So let's see, the first one here is initial access. And so I can go over here to initial access, maybe click on one of these techniques and then learn a little bit more about it and then how to mitigate it. So if I want to know kind of like, how do I get started with this investigation? I might want to follow the MITRE attack matrix for this. Now, I could see the alerts. There's 22 of them. We'll come back to that. I could see it affected 2 devices. And then I could see no identities, no users were impacted. That's good. No mailboxes either in Office 365. There's 2 automated investigations that got generated, which we'll come back to. And then immediately it found 29 pieces of evidence. I want to start here because this is so important to understand. And this is what just amazes me about Defender for Endpoint is to be able to do this manually could take hours or even days or weeks to be able to comb through files and processes on that machine. That means I have to take that machine, get an image of it, and then do memory dumps and do all sorts of other stuff to try to figure out what's happening with that machine that we're discovering, suspicious activity on. Well, the system already did that. And it discovered that there were 12 files that it deems to be suspicious. And then it found 10 processes it found to be suspicious. And it found 4 IP addresses that these machines are trying to communicate with that are suspicious. And it found some domains here that are also suspicious it's trying to communicate with. Folks, this would have taken a long time to be able to gather this evidence. This all happened instantaneously and automatically. Pretty cool. Now, what I could do is click on one of these pieces of evidence. And I have a couple of options available to me. I can click on Open and Explore, and that will open up this view. And then I can go see, is there any other communication here with that URL, maybe from Office 365, ATP, or Defender for Office. But what else I can do is I can click on Go Hunt. And this will open up Advanced Hunting. I can perform a KQL query to see where else in the environment are we seeing activity with this URL? So why is this important? Well, this is important because I want to know how did that URL get accessed in the first place? Because I don't know at this point, right? Was it a piece of malware that called that URL or was it an end user clicking on a phishing link on that machine? And so this will help me really understand a little bit more about that. Okay. And then if we click on processes and files and we click on one of these, I can go out and do similar things. So this is extremely important, this evidence and response. So immediately I know that, all right, we found some suspicious files. So what do I do about that? Well, immediately I could click on the file and I could see all this kind of metadata associated with it, right? But I'm just going to click on Open File Page. And we're going to cut straight to the chase here. So immediately I can see the file hashes associated with it. I can also see a couple other things here. Virus total ratio. If you've never used virus total before, this is amazing. In fact, let's just open this up here in a new tab. And so a virus total is a service that allows you to upload a file, and you can even do this with a URL, and it will scan it against, in this case, 68 virus engines. And 58 of those 68 came back to find that piece of malware. Look at this. And where's Microsoft? There's Microsoft. So all these virus engines, all 58 of them, found this piece of file to be malicious. Now there's some here that did not find it to be malicious, and that's a little alarming or concerning. And so immediately I know that this thing is probably malicious. And then I could also see that Microsoft has cataloged it as malware. And I can look at the details of that as well. Okay, if I click on alerts, I can see which alerts in the system correspond to this file, which we'll come back to. I can see where in the organization this has been observed. So it's been observed on 3 different machines. And then I can see what other file names this file is going by. And then I can click on Deep Analysis, and I can do a sandbox of this. So I could take the file, take a copy of it, I could upload it to the cloud service here, and within a little bit of time, it will go through, it will sandbox it, and it will tell you what behaviors it's observing here. So here it observed, it's trying to do some registry changes, trying to do some process injection and some other stuff that might be kind of nasty. That saves me a lot of time. Otherwise, I'd have to download the file and then go, put in an air-gapped network and try to reverse engineer it. So this saves a lot of time. Now, what do I do to be able to respond to this? Well, since this thing is probably malicious based on all this telemetry I'm seeing, I'm going to want to do two things. The first one is click on Stop and Quarantine File. And this allows me to take that file anywhere it's located in the environment and stop the process from running and then quarantine the file. So we're going to do that. So immediately we start our cleanup efforts. Let's just kill this process from running on every device. That's the starting point. Now, I'm also going to want to add an indicator of compromise. And this says that anywhere in the environment we discover this file, or on any new machine we discover this file, create an alert, and then block that file from being executed. So we're just going to put SUNBURST malware detected and give it a high severity, and then give it a category of malware, and description is going to be demo. Whoops, that's not demo. That's demo. And then we're going to scope to all devices and then create it. So now anywhere in the environment, it sees this file, maybe on a new machine, it's going to immediately stop it from running. So we stopped and quarantined, and then we create an IOC. Now you might be wondering where these IOCs are located. Well, watch my other videos, but if you come over here on the hamburger menu and you scroll down to Settings, and I'm just going to open this in a new tab so we don't get lost here. When you go to Settings, click on Endpoints, and then scroll down to the bottom and find Indicators. These are indicators of compromise. So there's the file hash that I just created. Pretty cool. Okay. So now let's go back to our incident, and let's go and let's start running through the evidence again. So we ran through a file, and remember there's some other files here too that might be suspicious. We'll come back to those. It found some suspicious processes, which we'll come back to as well. But let's go to IP addresses. This tells me it's probably communicating with a command and control server. And so what I could do is then take one of these IP addresses, and I can add an IOC for it. So, and by the way, I can look at the geo information here and see a little bit more about that IP address, and I can create an IOC for it. But actually, I'm going to wait. Let's come back to that. Okay. Now, I want to click on Investigations. This is where the system kicked off some automated investigations. 2 of these automated investigations, or auto IR as it's referred to. One on test machine 1 and one on test machine 3, which if I remember correctly, those are both Windows 10 machines. So we're going to click on the first one and open up the investigation page. Now, this will tell me a little bit about the investigation. So it ran on test machine 1. It analyzed all of these different entities, which could take a human a long time to do. And then it found some evidence, as we talked about before. Now, remember, this is just a simulation, so no real threats were actually found. But what happened here was it generated an alert during the investigation. It found that suspicious file. It found on that one device. It discovered that evidence, which we just talked about. And then if I click on entities, here's all the stuff that it analyzed. So if I really wanted to, I can go through here and I can, go analyze everything that the system analyzed. And if I click on log, it will tell me step by step what it did. Okay, so it checked to see is there any machines in the environment that have this, and get a list of active processes and analyze those files and yada, yada, yada. If this was a real attack, you would also see things in here like, hey, it quarantined the file. It ended the process. It killed the service. It did a few other things. So this is, again, extremely useful. This automation can save your endpoint. So let's go back to the incident, and let's go back to investigations, and let's click on this second investigation. And I promise all of this will make sense here in just a moment when we run through the white paper. So here's that second investigation that was created. It discovered some alerts as it analyzed all these entities. It discovered some pieces of evidence. That's the malware, bdata.bin. And then it ran through its analysis of those entities and it logged all that activity. Again, if this was real world, this auto IR would have also started doing automatic mitigation as well. Okay, back to the incident. Let's run through this. So let's clean up the real estate here, make this a little bit bigger. And let's take that white paper that I talked about and let's read this together. Okay, SUNBURST malware is the first one. This is interesting. The initial stage of the attack was the deployment of SUNBURST, which occurred after updating SolarWinds Orion to a compromised version. This DLL allowed attackers to gain backdoor access to affected devices. So the simulator writes SUNBURST to disk as a file named bdata.bin and removes it after 20 seconds. The hash is 1 echo echo Charlie. And it wants you to search for alerts called SolarWinds malicious binaries associated with the supply chain attack. Okay, so let's go find that. So let's go back to our incident. Let's click on alerts. And let's look. Do you see it? I see it. Right here, fourth one down. All right, so in the process tree, we could see this was on test machine 3, running under the context of system. I can see that the simulator process launched. It then created a file and deployed that piece of malware, right? And it did this a few other times. Now, this is because I ran this on multiple machines, and these are also different pieces of malware, which we'll come back to in a second. But this one is 1 echo echo Charlie, which corresponds to SUNBURST, 1 echo echo Charlie. Now, you could create an advanced hunting query, a KQL query to go look for this. That's pretty easy, but I want to take you through the manual process here. So we know what's happening here. We know that this piece of malware got deployed. So I'm going to click on it, click on the name of the file until it turns blue. Now, there's a few things I can do here. I can see some context around that file. Notice it's signed. And then I can also see, that this was detected as a threat, and then there's the alerts that were generated because of it. But over on the right side, I've got all this information about that file. I like to have a clean view, so I click on Open File Page. And this allows me to view everything about the file. So I can see that, okay, it's signed, it's a portable executable. There's the file hash, and then there's virus total, which we already talked about. I can see what other devices in the organization this is discovered on. We've talked about deep analysis, file names, any other file names associated with it. So I can learn more about the file. Perfect. And then I can do my stop and quarantine. So let's go ahead and do that. Remember, this is for a different piece of malware. This is for SUNBURST. So we're going to stop and quarantine it, and then we're going to create an IOC. And we're just going to say SUNBURST malware found, and create a severity, create a category of malware, and then put demo here, and then next. Cool. All right. So now anywhere that file is discovered, the process is killed, the file is quarantined, and then we have an indicator created so that if it's discovered on a new device, it gets stopped as well. Okay, so that is SUNBURST. All right, let's move on. TEARDROP. In some cases, the attackers use the backdoor access. Okay, so SUNBURST deployed a backdoor, and then TEARDROP allows them to get hands-on keyboard capabilities through that backdoor. And this is called Cobalt Strike Beacon in memory. And it ends, the file hash ends in Echo 1 Charlie Foxtrot, and the name of the file is bdata.bin. And we want to look for SolarGate Cobalt Strike Beacon loaders associated with the supply chain attack. Okay, let's go look for it. So let's go back to our incident and click on alerts. And let's go look for it. Do you see it? I see it. Third one down. It found 2 alerts and it grouped them. So let's click on the first one. Aha. So this is running on test machine 3 under the system context. The simulator process launched, It deployed a file called bdata.bin, which we know is our piece of malware. When we click on it, we can open up the file page. We can see everything about that file. Looks like this one's not signed. And VirusTotal caught it, 58 out of 68. Microsoft also caught it. And again, I can stop and quarantine it. So let's just go ahead and do that. Demo is our reason. And then I've already created an indicator of compromise, if you remember. But I actually no, we're not going to. I was going to edit it, but let's not do that. And then we're ready to go on that file. Okay, so that is a little bit about that second stage payload called Teardrop. Okay, that's interesting. Let's move on. SUPERNOVA sounds interesting. Another payload detected around the same time was a web shell dubbed SUPERNOVA, a DLL that was embedded in some SolarWinds Orion installations. Unlike SUNBURST, this DLL was not signed with a legitimate certificate, and analysts are convinced that it's unrelated. Okay, interesting. Well, let's go look for it anyway. So it ends in 5 Echo 8, and it's called bdata.bin, and backdoor associated with Solarwinds vulnerability has been detected, which is the name of the alert. So let's go back to our incident and click on alerts. And sorry, the name of the alert was backdoor associated with the Solarwinds vulnerability has been detected. Do you see it? Second one down, there it is. Let's click on one, boom. Test machine 3 under the system context, simulator launched. It then launched it then created that file and deployed it, which we know is malware. And then 5 Echo 8, there it is. 5 Echo 8 is the hash, so that's SUPERNOVA. So this is classified as SUPERNOVA. So let's open up the file page. VirusTotal discovered it, 58 virus engines. And we can go ahead and do our response here, stop and quarantine the file. I've already created an IOC, so we can edit that if we needed to. Okay, so that is SUPERNOVA. Interesting. So we've got SUNBURST, Teardrop, and SUPERNOVA. Those are the 3 types of malware. So now let's move on. So once SUNBURST has been installed, remember that's a backdoor, it's going to go communicate with its command and control server. And those command and control servers are located on a few different domains, avsvmcloud.com, and there's some other domains. So we need to go look for alerts that are called Nobelium Activity Group and Solargate Cobalt Strike network traffic. Okay, so let's go back to our incident. Let's click on alerts. And let's find it. Do you see it? There it is. Nobelium Activity Group. Okay, test machine 3 under the system context. The simulator launched. It deployed that piece of malware. Deployed a few pieces of malware, actually. SUNBURST, SUPERNOVA, and Teardrop. And then look at that. Network connection. Outbound connection to 198.12.75.112 on port 80. That's the HTTP GET that it was talking about. Remember? Right here. And if we click on that IP address, it turns blue. Look at that. I can see the resolved domain. Now, it's not the same domain that it listed here, but remember it also said and others. So that's one of the other domains. Whoops. See behind the scenes there. So I'm going to click on this so it turns blue. We're going to open up the IP address page. So this is where I can see the GeoIP information. Interesting, coming out of Casper, Wyoming. I can see where all we've observed this network communication in the organization across all 3 devices here in my simulation. And then I'm going to respond to it. So we're going to create an indicator. So remember, the indicator is going to stop all communication with that IP address and any future communication with that IP address. So not only create an alert, but block it. So what do we want to call this thing? Communication with SUNBURST server. So let's just put SUNBURST CNC activity detected. And severity is high. And then category is command and control. And then description's demo. So anywhere we see communication with this IP address, we're going to alert and then block that communication. Okay. Interesting. Now, if we go back to the alert right here, and we scroll down, is there any other IP addresses? So there's 198.12. Ah, look at that, 172.97. Let's take a look at him. On port 80, so it's part of the HTTP GET. Oh, new domain this time, mobile and web. Let's open up the IP address page. This time it's coming out of Miami. We've seen it across how many devices? Probably all 3, but let's take a look. Great. All 3 devices. We have a heat wave here in San Diego. I was about to blame it on the heat. So let's go ahead and create an IOC for it. So anywhere we see communication, we're going to block it and create an alert. And alert severity is high. Command controls the category, and we're just doing a demo. Cool, save. All right, so now let's go back. Actually, no, let's go back to our alert. I'm just kind of curious. Let's see, is there any other new IP addresses here? 198.172, oh, 204. How could we forget 204? Infinity Softwares. Interesting. This one's coming out of Road Town, Virgin Islands. I've never been there. Have you? I would love to go to Virgin Islands. I've heard it's beautiful. Okay, so let's create an indicator of compromise here. So anywhere we see communication with this 204 address, we block it. So SUNBURST, CNC activity detected. You could say blocked, I suppose. But hey, this is just a demo. All right. Cool. All right, so that's command and control server activity. Moving on, WMI event subscription. Now, I am not a WMI expert by any means, so if any of you out there could explain what you're about to see, put it in the comments. I would love to learn a little bit more about WMI. I probably should know more, but I just haven't worked enough with it. But let's check it out here. Okay, so this was also observed. And look at that. There's the MITRE tactic and technique that's observed with it. So this is using, WMI event subscription. Here's some examples of it seen out in the wild by MITRE. Here's how you can mitigate it and some additional references. So that might be helpful for some of you. So this step simulates obtaining persistence using WMI event subscription. To do that, the simulator drops a PowerShell script that upon execution binds certain changes to the system uptime value to execution of a binary file, sbdata.exe. A very similar implementation of this technique was observed in the campaign. Investigation tips. Search for an alert. WMI filter was bound to a suspicious event consumer. Okay, let's go look for it. Go back to our original incident, click on alerts. And there it is. Look at that, hovered right over it. WMI event filter was bound to a suspicious consumer. Now, I'm not a WMI expert. I probably should be, but I would love to learn a little bit more about like what this is actually doing. So if any of you want to let me know in the comments, I would love to learn more about it. And there's the MITRE technique that we already talked about that it maps to. So there you have it. Now, what I could do is I can block this activity by creating an attack surface reduction rule. Go watch my other videos on ASR rules. These things are amazing. Had the ASR rule been in place, this could have been blocked. So you can find this recommendation on the device page under security recommendations. Since ASR rules are on audit mode by default, you can see this rule was triggered by performing the following. Okay, we'll come back to advanced hunting here in a second. So let's go look at the device page. Now this was running on test machine 1. So we're going to click on the name of the device and click on open machine page or open device page. And we'll see a little bit about the device, but let's click on security recommendations and scroll down. And we should be able to find an ASR rule. I'm going to zoom out just a little bit. There we go. Related components, attack surface reduction. There it is. Block persistence through WMI event subscription. Tells me a little bit more about what it is. I can read more about the recommendation. Go see how to do it. I'll do another video on all about this later. So there it is. So this could have been blocked and prevented had I had that ASR rule right there. Now, you know what else I could do is we can create an advanced hunting query. So let's go do that. Since ASR rules are on audit mode by default, you can see that this rule was triggered. So this could be very useful. If you know anything about attack surface reduction, go watch my videos on this, but I can create an advanced hunting query. Advanced hunting, where are you? Hunting, advanced hunting. And that hunting query can be used to find this across any other device in the environment. It can be used to it could be used to identify this activity on any device, but you have to actually name the device here using the host name. Now you probably could edit this and just go look for it across the environment, like that. But there you go. We'll do another session on advanced hunting. I don't want to go too deep into it right now because there's a lot to talk about there. Okay. Now you could enable ASR on that VM and then rerun the simulation and see it get blocked. And in fact, if we go over here to the page and then we scroll down to configuration management under endpoints and we click on device attack surface management. I said I didn't want to go into ASR, but I'm going to go a little bit into ASR. And I click on detections. Here's some different things that it noticed that an ASR rule could have blocked. So this was using the LSAS service to do some credential stealing. Had I had that ASR rule enabled, it probably could have blocked it. And then I could see which devices in my environment have those rules enabled. Anyway, I digress. Now, what I do want to do is go back to our incident go back to our white paper. And I want to go through this last one. So there's just one more left. Windows system data collection using CMD. In many cases, the attacker behind the campaign executed various commands via an intermediate command.exe/c process launched from Cobalt Strike main parent process. This step of the simulation mimics that technique and executes the following commands. Net sh firewall shows state, net users, net accounts, net session. Interesting. So go look for alerts called suspicious security to software discovery, suspicious system network configuration discovery, and suspicious system hardware discovery. All right, so let's go look. Let's open up our incident. Let's go to alerts. And possible RDP brute force attack, suspicious file was observed, password policy discovery, Let's use that one. Password policy discovery. Look at that. So on test machine 1, under the system context, the simulator process loaded its malware like we talked about before, but then it executed a command and /c, command.exe/c, echo, null. Interesting. And we could see it was executed using system level permissions. And then it performed a net accounts, just like the white paper said. All right. Now, if we go back to the white paper, we can go use an advanced hunting query to go look at this as well. So let's do that. Copy. And advanced hunting. Run query. Oh, I got to put in the name of the device. Test machine 1. And there it is. I could export that out to CSV, clean it up a little bit, but I can get all of the activity there. And look at that. There's that NetSH firewall, show state and exit that the white paper talked about. Now I could click on take actions. This is pretty cool. So based on this query, and I need to do a video on this because there's so much to talk about here. But based on this query, you can actually have it take an action. In fact, let's just cancel out of that for a second. And we're just going to do create detection rule. Yeah, okay. I need to add those. Not a problem. Let's click on take actions back here. Give this a second. And I could say, okay, on any device that this is in scope, I could isolate. This is kind of grayed out here, but I can isolate the device. I can run an antivirus scan. I could do a number of different things. So I could basically create my own detection rule based on that query and then take action based on what it found. We'll do another video on that because that's extremely powerful. Okay, so that's the end of the white paper. Oh, look at that. And then it talks about select create detection rule to create a custom rule. Yeah, we'll do another video on that. So that is exploring the SolarWinds attack thing I want to talk about here, and that's around the device. And I should have talked about this first, but if we go to devices and I choose both devices here, I can set some tags about those devices like, hey, these might be compromised, but they're also identified as being evaluation devices. But if I pull up one of these devices, because the risk level is high, and because we identified that malware and that CNC activity occurring on that device, I might want to isolate it. So if I come up here and just click on isolate device, this will actually shut off all network activity with the exception of the Defender for Endpoint service. Now I could check the box and allow the user to still use the device, but I don't want to because this device might be compromised. And when I click on confirm, it actually isolates that device from the network. Now that's important because that might be part of my response plan here. Immediately, let's isolate that device. Now I can automate this through Power Automate or even through that advanced hunting query and creating a custom detection rule like you saw before. Now I could also restrict app execution on the device and say, do not allow anything to run unless it's signed by Microsoft. Whoops. Do not allow anything to run unless it's signed by Microsoft. I could do that as well. I can kick off an antivirus scan, and then I can initiate a live response session. And when I try to initiate a live response session, of course, the device needs to be powered on. Now, remember, this device is expired in my evaluation lab, so that's why I don't see this. But when I try to do a live response session, it actually opens a console to the device, and I can run commands against it, scripts, and try to extract memory dumps and other things. So keep that in mind, folks, that there's a lot of ways here with Defender for Endpoint and Microsoft 365 Defender to not only detect this suspicious activity, but also automatically respond. And then the tools are here as well if you want to manually respond to be able to be more efficient. Okay, so I hope you found some value in this. If you did, give me a thumbs up. I would love to hear your feedback as well, as always. And just let me know in the comments section. But stay tuned. I got some more videos I'm doing today on Defender for Endpoint and Microsoft 365 Defender. So we will see you all in the next video. Take care.